and welcome back to another Logs.io training session. My name is Sean Pitts, and today we're going to be talking about the two query languages we use to search across logs within Logs.io. Now, there are two different languages that we have exposed to users, and that is the Lucene syntax that was created by Elastic and was used to query within Kibana, and then also we have the OpenSearch dashboards query language, which was used to query across OpenSearch dashboards. Now, Logs.io supports both of these query languages, and they're very straightforward, which we will cover today. You may be thinking to yourself, oh gosh, I gotta learn another query language. I already know three. I already write SQL queries. I already write Python. I already write JavaScript. Why do I have to learn another language? And really, it's not that overwhelming, and we're gonna kind of cover it today, so you will have a very good idea of how to query across logs within Logs.io. So let's jump right in. So when we get into Logs.io, our logs are going to be coming in and they're going to look something like the following. We're going to have our timestamp and then we're going to have our message. However, when logs come into Logs.io, they are parsed out, meaning there is fields extracted from these logs. So let's collapse this and we'll see what this looks like in terms of fields. You can see we have fields like the message, the method, the path, the request time, etc. And all of these fields are mapped as a specific type, whether it's a string, a number, such as a long or a float. All those can be broken down into the other video I created, which I will link here, and that is on our field mapping, right? So give that video a watch if you want. It's really useful and it's good background knowledge. So now that we have our types, we can kind of use these to our advantage to query across logs, right? If we don't have these fields extracted out to us, you can reach out to support. Maybe you have something like a source IP, or you have a date, or you have a GET request being made in your log and you want to see that, or the user agent, whatever it is, right? Logs.io support is always there to help parse out these logs. Now, if we want to do a very broad-based search, let's say we just want to query across all logs that have login within our message. We can do a broad-based search. Reason we can do that is the message field, which is what the raw log comes in under, is a text analyzed field, which means we can just do very broad-based searches across it. There are faults to this, meaning that your query times can be slow if you do broad-based searches like this, depending on how many logs you're querying across. In this case, I only have 123 in the last 15 minutes I'm querying across. But what if I'm querying 5 million logs within the last 5 minutes, right? That can be very cumbersome and it can be not that performant. So what we want to do is we want to actually use key value pairs to query within Lucene. So if we once again collapse this log, you can see that we matched our login, which is the broad-based text search we're using. However, if I wanted to search for all logs that have a path of login, it's very straightforward. I just reference the field name, which is here on the left, and then I will, in quotes, add my value that I want to search across. So in this case, it's path, and I'm searching for every path that has a login. If I want to see that and make sure that I am matching these, I can query on the available field into our column view, and you can see that we have this highlighted in yellow. Now, if we want to get rid of this message field and just see all these logs, we can. So what if I also want to chain on a logical operation, such as an and or an or? That's very easy as well. So let's say I want to also look at all my request times that are above 3 seconds. You can see that I have a various amount of request times that my Nginx server is making. So let's say I want to do everything over 3. What I can do, because this is a numerical field, request time being mapped as a number, and we can see that with the number sign, we can say and request time, and then we do colon, greater than, and then we can say 3. So now what you're going to see is everything is over or greater than 3. If I want to do less than, I can do that as well, less than or equal to, and so forth, right? Now what if I want to set a range in a numerical parameter or a numerical field? What I can do is I can say 3.0 to 4.0, and I'll get everything for request times from 3 to 4. And that also goes for status codes. So let's say we wanted, let's say we toggle on the status field, and we can see we get 201s, 404s, 500s, so forth. If I just want to do give me status codes that are 200 to 299. Very easy, right? All I have to do is query it as such, and I will get all my parameters as path is login and status is 200 to 299. You can see that we're getting invalid query here. And if we look at why this is, it's because 2 is in lowercase, which is an important thing to remember because I just fumbled that. So 2 has to be all uppercase. And you can see now that I'm only getting 200 status codes and either path login, but I'm getting all my request times depending on the duration. It doesn't matter at this point. So now that I have my query made to search for path login and status is either 200 to 299, I can start to actually query based on the source IP field. So let's say I want to dynamically create a filter, or I want to search across source IPs that start with 1 instead of 2, right? So maybe I have a 236.4.4203 and I don't want those, right? I can actually do a not. So what I can do here is chain on another and say and not, and then I can do a broad-based or wildcard search essentially to filter out all those 200s I don't want. So in this case 236, we have something like 248, and I don't want that, right? So I can do 2, and then I can do a wildcard, which is an asterisk. And then when we query across this, you'll see that I get everything that's not in the 200. So my source IP is 170, 145, 133, 19, so forth. Those are all going to match. If I want to change this and I want it to actually be all my source IPs that are 200 and above, I can get those, right? And that's what a wildcard search is powerful in doing, in case you don't know what those subnet masks are going to be or whatever the rest of the IP is going to be in this case. Now, there's important things to note about wildcard searches. And the first thing is that leading wildcards are not allowed. So let's say I didn't know what the IP is, but I knew what the subnet is, right? Maybe I know the subnet's going to be 60 and I want to match everything up to it. That will not work because Logs.io does not support leading wildcards. Reason being, it becomes extremely inefficient, especially if you're querying across a lot of logs and the message or whatever field you're searching across is extremely large, right? So it's important to note that is a limitation. Now, we've talked about ands, we've talked about logical operators, we've talked about or statements if I wanted to just change this to an or, and maybe I wanted to wrap this, so I wanted to say path is login and status is 200 to 299, or the source IP is 60, or in this case, let's do 127 IPs, right? We could do that as well. And we'll, based on that, have kind of this dynamic expression. Now, if we wanted to query this on to OpenSearch dashboard query language, very straightforward. You just go into the Lucene, click on it, and click on OpenSearch dashboard query language, and this will turn on. If we take a look at the docs that we provide, you'll see that it's very, very similar, right? We have a key value pair, which is the field, and then the value. We have key value pairs, and then we have things like the querying date ranges and numbers, which is a little bit different, right? Because before we had kind of this request time in Lucene, we had request time : greater than 1, for example, right? Now, if we query that, you'll see that Lucene syntax warning looks like you may be trying to use Lucene, even though you're not actually using Lucene, you're using DQL. So if we did request time is greater than 1, you'd see now this would work as expected because we're using the correct syntax. So essentially, the syntax behind DQL versus Lucene is a little bit different. Searching with Boolean queries is a little bit different. You can see that in Lucene we have this capitalized and we usually see. However, we can use a lowercase within DQL for or and statements. Now querying date ranges, very similar to what I just showed. But the best thing about DQL is how we actually query nested fields. So you can see here, for example, superheroes is an array, and what how Kibana handled that with Lucene, I do not believe is as good as the DQL language handles it because of the ability to actually retrieve nested fields within your document or log. So you can see that logs are essentially JSON. If you go into OpenSearch dashboards and we take a look at a log, you can see that everything's kind of in this JSON format. So if we collapse it and click on the JSON tab, this is how the log is ingested. Now, you can see that arrays are something that's been tricky within Kibana to deal with in terms of parsing those fields out. However, if you want to retrieve documents that match a specific field, you can use this nested language. Querying doubly nested objects are even better. So you can see that Justice League in this case is an array, and then we have Superheroes, which is an array, and then it has an array of objects. So how do you kind of query these nested objects within this array, right? So the coolest thing about this is you can see, for example, here in the documentation, it says Justice League.superheroes. So we're referencing that nested object under the Justice League array. However, we can now define properties or items indices within the array under Justice League Superheroes, which is really cool because in Kibana and Lucene, we're sort of limited to how we can do that. And that's why I believe DQL is a lot more powerful when it comes to this use case. So if you ever need to query across arrays, this is something that I believe you should look into. Now, if you ever have a problem with writing a Lucene Lucene query, or a DQL query, always reach out to support. They can help with this. And I will catch you in the next session. Have a good day, everyone.